Earth has had many interactions with asteroids and other near-Earth objects in its existence. They come in many sizes and shapes, and as we have learned, are hard to accurately predict the trajectory of them. NASA and other space organizations have been closely watching near-Earth objects with the goal of identifying them and predicting their trajectories so Earth is protected from them. In the early 2000s, a near 30 billion kilogram asteroid named Apophis 99942 was detected with a small chance of hitting Earth in 2029, and regardless of a miss, it is said to travel around 30,000 kilometers from Earth. So what does this mean for Earth? Well, it means we have to think of something to make it a 0% chance of hitting, because as much as we can predict, we can't guarantee the trajectory of the asteroid until it would be too late to stop. There have been many theorized ideas, most have had limited testing, however I believe one idea could be predominantly easier and more effective than the others. Let alone diverting Apophis 99942 away from Earth, it could be used in the future of Earth's protection. The idea is to attach a solar sail to an asteroid. This way, with a transfer of momentum, we can use photons from the sun to alter the trajectory of it. Solar sails capture energy from the light particles when they reflect the light off of their surface. This interaction transfers momentum from the photons to the sail. The solar sail is computer controlled to create dark and bright sides on the surface, which allow for the steering of the asteroid. This is similar to how the Japanese exploration spacecraft Icarus traversed its way from Earth to Venus in 7 months. All this leads to the question of how does this momentum translate to moving an asteroid? We must turn the momentum of the photons into acceleration of the solar sail to be able to push the asteroid off its path. Knowing that force is equal to mass times acceleration, or mass times velocity divided by time, as well as that mass times velocity is equal to momentum, we can determine that the force of the photons will be equal to their momentum divided by the time that they contact the solar sail. Now remembering that photons don't have mass, we must input Einstein's idea of mass equivalence to determine overall that the force equals Planck's constant divided by the wavelength times the time of contact. This helps us in determining the force with which a photon will be contacting our solar sail with. What follows is now determining how this changes our asteroid's acceleration. The acceleration determines how fast the asteroid's position can be altered and how long it will take until the asteroid is no longer a threat. This portion can vary depending on the size of the asteroid as well as the area of the solar sail. This is because the larger the area, the more sunlight and photons which will make contact with it, altering the overall force that is applied by the photons. For determining the acceleration that will be caused on the asteroid thanks to the solar sail, it will equal the net force of all the photons, or the overall power of the sunlight, divided by the mass of the asteroid. An asteroid strike is never out of the realm of possibilities on Earth, and with its difficulty to predict and monitor, scientists must be prepared with a variety of methods to divert these asteroids from striking Earth, and I think a solar sail could be a very viable option in stopping a repeat of what possibly made the dinosaurs go extinct 65 million years ago.